Okay, hello and welcome to video 5. And finally, we are on to things which are maybe less obvious and less well known. And this is where I actually think that you may start getting some material that is maybe not mentioned elsewhere or not emphasized. And this is the first section for that. So make sure you pay attention in this video. So the first big topic I want to talk about is the idea of graphs and the fact that I think that they're severely underutilized in most GMAT prep materials. Graphs are incredibly useful to just solve a huge range of problems very, very easily. And I'll give a few examples here, but you'll see a lot more examples in the accompanying questions video of me just defaulting to using graphs to determine answers to problems, especially using the multiple choice nature of the GMAT. Graphs are just incredibly useful, and I really strongly recommend you just practice with them until you're extremely comfortable at sketching them very quickly, and you're just very comfortable and it's second nature for you to use them. So just quickly to provide a bit more motivation, why are graphs so useful? Well, inequalities, graphs are extremely important for. We'll see examples for that. Effectively, they can make inequalities questions incredibly easy that would be almost impossible otherwise. Similarly, for number of solutions questions, graphs just make very, very quick work of them. And also, graphs will tell you roughly the size of solutions and where they occur. So effectively, what they allow you to do is just use the multiple choice method to your advantage, in that the graphs will tell you how many solutions there are and roughly how big they are. And so you can just pick the answer out of the 5 that are available. So in order to use graphs, there's only a few things you really need to know, which is how to sketch a few of them. We've already covered quadratics, but make sure you can do those, and linear, obviously. But then there's a few more that I want to mention that are less common. So the first one is reciprocal, or in other words, 1 over x. And graphs are, in the GMAT, you're not going to be asked to sketch any particularly hard graphs. So all you need to do is know these simple graphs. And if you're not sure if there's a slight twist on them, just try plotting some points. But you really shouldn't come across many strange ones. So it's useful to know the reciprocal graph, 1 over x, simply looks like this. And it should make a lot of sense to you if you just try plugging in some numbers. Effectively, it just does this. So it's positive on that side and negative on that side, and goes through the point 1, 1, which should make sense. And then there's some twists on the reciprocal graph. For example, 1 over x squared is just going to look like, well, almost exactly the same thing. But then if you think about the left-hand side, when x is negative, well, x squared is still positive. So it's just going to end up looking like that. So that's one very important graph to know. Just make sure you can sketch a reciprocal extremely quickly. Square root. Again, very simple. It's just like a quadratic, but on its side and only one part of it. So it's just like that. And again, it goes through the point 1, 1. Okay, and then we have the simple x squared graph, which we've already mentioned, but just does that. And I just want to draw attention to the fact that that also goes through the point 1, 1. Okay, so those are the first sort of simple set of graphs. Just make sure you immediately can sketch those, as well as quadratics of many types. The next thing I want to start talking about is cubics. Now, cubics in general, and by cubics I mean anything in this form, x cubed plus some lower powers of x equals 0. Cubics in general, you can't really sketch them very easily, and it's quite unlikely that you're given a cubic in the general form. So in other words, you sort of need to be able to factorize the cubic, which they'll either give it to you already, or it will be in a very simple form to do. For example, if I have something like this, that's something you might see in the GMAT, in which case you just sort of start by factorizing out the x, and that leaves us with a quadratic, which we can then factorize as well. At which point, once you've factorized a cubic, it's very easy to sketch the graph. So it's not really worth trying to sketch cubics if you can't factorize it, but usually in the GMAT, you'll be given a factorized form for the cubic. Or it will just be very simple and just be x cubed. So the reason why you want to factorize is simply because that tells you immediately where it's 0. So we've got x equals 0 and x equals -1. And effectively positive cubics, so positive x cubed, you know that it ends up shooting off up there and shooting off down here. Becomes very positive and very negative. And then all you need to do is sort of join the dots up. One important thing to know is that repeated roots like this, where it's a squared, like with quadratics, that means it just touches the axis there. It doesn't go through. And so with that knowledge, the only way we can make this cubic work is if I just sort of join this up, touch the axis there, go back down, and then come up. And that will be the cubic. For example, make sure this can be a bit trickier than it sounds at first, but once you get used to it, it's very, very simple. So for example, if I want to sketch x minus 2, x plus 2, again, something very commonly that you'll see. Well, we know it goes through 0, 2, and -2. There's no repeated roots, so it just sort of has to come up from down here, go through, turn around, go back down, and then come up. Now, we'll see why. Just sort of trust me at the moment that being able to sketch these is very, very helpful. You'll see why very shortly, but just make sure you get some practice at this. Let's do one more type. X minus 1 squared. Well, again, we can just sort of label on where it goes through the axis. So 0 and 1. We know that this x minus 1 squared must be just touching. So again, just sort of come up, say, okay, well, we have to go through here, and then we just have to touch there, and then we're done. So you can see it's very simple. Make sure you're very comfortable with sketching cubics. Okay, and then the final type of graph, perhaps the most useful and the least used in terms of materials I've seen, are modulus graphs. Now, these are actually, I mean, I'm very surprised that they're not used very much, because they really do just solve modulus questions, especially the hard ones, very easily. So, and they're not very hard to sketch. So let's just give an example. Y equals mod 2x minus 3. Okay, so the way I always think about sketching these is just all you're doing is you're looking for the one point. You want to look for where the modulus is 0 first, and that's sort of your critical point. So here we're going to say that, okay, at x equals 3 over 2, then the modulus is 0. So we know that this goes through the point 3 over 2, 0. And then we're basically done, because all you need to do is say, okay, to the right of that point, we've got a gradient of 2. So I'm just going up like that. It's just a straight line. And then to the left of that point, we'd sort of flip the modulus around. You can imagine it becoming minus 2x plus 3, but you don't really have to worry about that because you'll get very used to this. It's just going to be sort of an arrow shape. So it does that. And that's all there is to sketching modulus graphs. So let's just do another one quickly. For example, y equals x plus 3 plus 5. Okay, so, well, look for where it's 0. So at x equals minus 3, we know that the modulus is 0, but obviously we've still got a plus 5, so we must be at minus 3, 5 there. And then just to the right of it, it's got a gradient of 1, so we're just going to go up like that, and then we sort of complete our arrow, gradient of minus 1, and that's it. Okay, then there's one more type of modulus graph that I want to sort of mention that's particularly nasty, much harder to sketch, but to be honest, it's worth knowing. If you have something like this, let's do a few types of these, where you've got both types of modulus. You've got two moduluses. So this is going to be slightly harder to sketch. So you want to do the same sort of method though. You just want to say, okay, the important points are x equals minus 3 and x equals minus 5. And so then what we can do is we can say, okay, above the largest one, so above minus 3, we should have just both of them being positive. So what we can do is say, okay, so at minus 3, what value does this take? Well, we've just got this first one is 0, and this second one, minus 3 plus 5 is 2, so we know we're at 2. And so above that point, both of them are positive, so we'll just have plus 2x. So it's going to be quite steep and just up like that. And then when we swap, then when we go to the left of minus 3, all the way until we reach minus 5, then, well, what's going to happen? One of the x's is going to become a minus x. And so something strange happens, which is very important for moduluses, which is that the x terms cancel out. And so we're literally just going to get a straight line until this point. I'll go a bit more into detail on that in a second. And then past the next point, they'll both become minus. And so we'll just go back up. So that's what that ends up looking like. Obviously much harder to sketch, but not impossible. And so let's talk through that a bit more sort of methodically in terms of how you can learn to start doing that. So what I would say is what you want to do is you want to start off by dividing it into those regions, as I did there, x equals minus 3 and x equals minus 5. And so what we're going to do is we're just going to say, okay, for x is greater than minus 3, we're going to get a certain function. For, in fact, let me write this elsewhere. So we're going to split this into the regions depending on what happens at various values of x. So for x is greater than minus 3, we've got a certain thing going on. Then between minus 5 and minus 3, we've got something else going on. And then less than minus 5, we've got something else. And so then all I'm going to do is I'm going to say, well, what is y? Well, above minus 3, both of them are positive. So we can just get rid of the modular signs and say that's 2x plus 8. Then between minus 5 and minus 3, well, who's changed? It's actually just the x plus 3 term has become negative. So that's going to swap. And so we're going to get, the other one is x plus 5, and this new one is minus x minus 3. So that will just simplify into, I believe it's just 2. So that's the value of the function between minus 5 and minus 3. And then for x is less than minus 5, well, they're both just negative. So we know it's minus 2x minus 8. And so that's how you sort of actually find what the functions are at each point. And that's sort of, if you look at that, you can see why we've got that weird graph there. So that's just sort of a quick mention on how to sketch modulus graphs. You wouldn't usually get something as complicated as this in most questions. And if you do, it's usually just sort of, there's easier ways of doing it. You can just sort of plug in values, but just for completeness, I'll mention that there. But just make sure you can sketch these types because they're very, very helpful to be able to just do quickly. And that's it in terms of graphs I would recommend knowing. So you can see it's not that many. And I'm now going to just sort of come up with examples of things I've seen, which without graphs are pretty nasty to deal with, to be honest. And graphs just allow you to skip a bunch of algebra, and you're much more likely to get things correct. So let's say, for example, how many solutions to okay, something like that. So algebraically, that's going to be, in fact, let's make it a bit nastier. Okay, algebraically, that's going to be a complete pain to solve, but just using our graph sketching knowledge, what you want to do is just sketch what's on the left-hand side and then sketch what's on the right-hand side and see where they intersect, because that's a solution. Where they intersect is the solution. So, for example, I'm just showing you how quickly, if you get good at this, how quickly you can do this. Well, mod x plus 5, so that's at x equals minus 5, and it's going to have a gradient of 1. So we can do that guy like that. And then the other one, 2x minus 3, so that's at x equals 3 over 2. And we know it's minus 3, so we have to shift it down a bit. Okay. And then, well, we know it's got a gradient of 2, so that's steeper. So he's going to go up like that. And so obviously that's going to intersect eventually with him. And then also he's going to go up very steeply there. He's going to intersect there. And these guys are never going to intersect because this guy's steeper. So the answer is simply 2 solutions. And if you had to know how big they are, well, you can now use the multiple choice answers to figure out, well, where are the solutions? Well, about -1 and 10 or something like that, right? You can get an idea for roughly how big they are. And okay, so then using that, let's just make a small twist on the question, which for a lot of people would make this extremely annoying. If instead of how many solutions, if it asked for what values of x is x plus 5 less than 2x minus 3 minus 3. So we're not going to do anything else. I've sketched this out. And so now all we need to do is say, well, when is purple, the purple graph, which is x plus 5, when is that less than the blue graph? Well, it looks to me like it's less than the blue graph in anywhere to the left of this point. It's always less than it over there. Blue is above purple. But also we can see that it's going to be also less than the blue graph anywhere to the right of this point. And so I'm not going to solve it, because just using the multiple choice answers, you'll be able to see which one that is. They're not going to be sort of ambiguous enough to know. You're going to be able to figure out which answer it is just based on those regions. So you can see that graphs can, I mean, I don't know, you may have a different method for doing this kind of thing, but it can make some very nasty questions very easy. Let's just do another example. Okay, so this was a very nasty question I've seen. This was a 700 to 800 level question. It was asking which of these can be possible. And algebraically, this is just a bit of a nightmare to try and figure out. So, I mean, just think about trying to solve that algebraically. You're going to be in quite a lot of trouble. But instead, I'm just going to say, okay, well, there's 3 things to sketch here. We're going to need to make sure we sketch it relatively well. We're only talking about x is greater than 0. So let's sketch the graph of x squared. So we can say that he definitely does something like that. And again, we know it goes through the point, and this is quite important, 1, 1. Okay, 2x, what does he do? Well, he's just a straight line up. We know he goes through the point 1, 2. And then sort of go up there. The x squared is going to overtake him at some point. And then 1 over x, what does he do? Well, he sort of comes down like this and also goes through the point 1, 1. Okay, and so now all we need to do is take a look. We've drawn that diagram, and so now all we need to do is look at these things and see if there's any region in the graph that obeys this. So part 1, x squared is the biggest, so we need to look for regions where purple is on top, which is only occurring sort of over here, like this kind of region. So x squared has to be on top, followed by 2x. Well, that's fine, you know, followed by 1 over x. Well, that's fine, because 1 over x at the bottom. So we've got that this guy can work. Then part 2, 1 over x is the biggest. Okay, so we're sort of working in this kind of region, followed by 2x. Yep, that looks fine. Followed by x squared. Well, that's fine. Okay, so that guy can work. And then the third one, 2x is the biggest. So that means we're sort of only in this kind of region, right? Because 2x is our highest guy there. Followed by 1 over x. Fine. That's okay. Followed by x squared. Well, that's fine. So that guy works as well. Whereas if I'd written down as an example, I believe 2x, if we'd had an option 4, 2x greater than x squared, greater than 1 over x, well, then we need 2x at the top, so we're in this region, greater than x squared, so we need to cross, oh no, we're still okay, because we can sort of go to there. That's greater than x squared, which is greater than 1 over x. So okay, so there's I think there is an ordering which doesn't work, but the point being that you can just sort of look at the graph once you sketch it out and solve. So you'll see a lot more examples of the usefulness of graphs in the question videos, but just make sure if you've not used graphs and you're not used to them, hopefully you can see that it's really not going to take you long to get practice at being able to sketch these quite simple graphs. And then once you're comfortable with that, you'll find that a lot of questions can just sort of be cheated on by using graphs. So hopefully that video makes sense, and we'll see you in the next one.